Hello. In the previous videos, we learned about the design build and compared it to design bid build. And we learned about that the success of the design build delivery of a project is really dependent on how the owner sets up this project delivery. And part of setting up a project delivery is in design build is communicating the requirements from the owner side to the design builder. So this is what we learn about in this video. And again, this is based on the DBIA best practices and certification training. So this graph here is really informative because it shows here how such definition of requirements and development of requirements matches with the level of detail in the design over the different phases of the design, and how these design requirements are communicated typically in design build projects. So the top kind of level here is the type of documents that are used in design build projects. So there's the criteria documents and the bridging documents. And when you do over the design kind of effort, there's the pre-design phase and the detail kind of design phase. So the pre-design phase matches with this level of detail or development of design. So there is the 0 to 5%, 5 to 20%, 20 to 35%, and then greater than 35%. So this second tier here is what's the emphasis from procurement perspective? So is it based on qualifications? Is it based on technical and price, or based on mainly lowest price? So that's procurement. This is the contractual documents that are being handed to the design builder. And this is kind of the approach of the design build, different variations of the design build. So there is the direct sole source selection. So you're going to a design builder because you see that they have the qualifications, because you don't have a lot of documents to share. So you depending on qualification to select the design builder. But when the owner does, depending on their own designer, they move into the design effort and do some effort in some design development here. So you move into 5 to 20%. Now you have more kind of polished criteria documents or some kind of bridging documents. So what's the difference? Criteria documents describes the end result. So I want this building, this height, this capacity. But then bridging documents start sketching that. So it prescribes how to achieve the end result. So I want this shape of the building because it allows this sun exposure, and you start sketching things. So when you go more and more into the design development effort, 5, 20 or 20, 30%, you're going into more, like you're starting now to sketch things. 0 to 5% is starting to setting the end result expectation. You didn't sketch anything yet. You're just trying to read the mind of the owner. So criteria documents, or the early kind of sketches of bridging documents, you will be able to select the design builder based on technical and price emphasis. So you can consider both. So that's called design criteria design builder. So this is if you have kind of still on the criteria documents kind of side of how you communicate the project requirements. Or if you start sketching things and you have now documents, bridging documents, this is called preliminary design build. So you're dealing or kind of getting into design build commitment based on some kind of preliminary design. Now, if the owner decides to put a lot of effort in design, more effort into design with their own private kind of architect and engineer, that will make them develop further the bridging documents up to a level of 35%. So that will allow them to push for selecting based on lowest price. So now all of that time until 35%, you don't have the design builder on board yet. So it's all kind of between the owner and their own design and architect team. So even the DBIA call this design slash draw build. So it's like there is no much design to be done. It's more about complete the design and draw and then build it. So it's that kind of handing or spoon feeding the design builder. I figure out what I want, I describe the end result, and then even sketched big part of this. So just take it, complete the drawing, permit it, and build it. So DBIA kind of encourages the owners to focus on this progressive kind of design build that depends on criteria documents and qualification based procurement. You can go a little into here, but they really hate that idea of the owner is working on their own with the designer. So it's almost like a design bid build. So here, this practice of design bid build, design DBIA 2C. So the DBIA is recommending that owners minimize the use of prescriptive requirements and maximize the use of performance-based requirements. So now we see two types of requirements that we will learn in this video. So you will minimize the use of prescriptive requirements if you minimize the dependence and production of bridging documents, because in bridging documents you start prescribing the outcome or the product instead of describing the end result. The end result is described by performance-based requirements. So in design bid build, the design details responsibility falls on the owner. So the owner has that responsibility to work really hard with the designer to finish 100% of the design, package it in a bid, ship it, and ask the contractors to bid it. So the owner here is responsible for the success or failure of that design and warrants the sufficiency of the design to the contractor. So the contractor is just pure contractor. They just take the design. It's kind of a recipe for building it. The owner is responsible or liable for any gaps then between the design documents and plans and specs, and also the ability of these plans and specs to fulfill the owner requirements in terms of the end result. The contractor is not responsible for the end result in this case. So here in design bid build, the owner packages the plans and specs together in a bid process, and they end up, when they selected a builder, a contractor, these plans and specs are part of the contract, and they should be are expected to be 100% complete. Now, in the design build side of the business, here the owner defines the project performance requirements and award the contract based on a basis of preliminary design. So they define the requirements, the performance requirement, not prescriptive requirements, and in return they get the basis, a preliminary design that they will use it to select the design builder. So the design builder here has a couple of responsibilities. They're responsible for completing the design, following these performance requirements provided by the owner. The design builder warrants the sufficiency of design to meet the owner requirements or criteria. And also on the other side, they look to the kind of the other side of the supply chain, to the subs and suppliers, and they warrant the sufficiency of the design to them. So it's not the owner now providing sufficiency of design to builders or sub-builders or trade builders. So here the design builder takes on now a lot of responsibility. So the purpose here of the completed design and plans and specifications is to enable the design builder to build a project, which are developed by the design builder. But the owner here does not provide the plans and specs. So the owner provides in the RFP, the request for proposal, the requirement to have a technical proposal and a price proposal. And the owner here just asks for that based on performance requirements that they provide. And when the design builder provides the RFP and they get selected, they provide preliminary design that's less than 100% complete, but that will be used to be selected and have a contract here. And this contract then will result in plans and specs that will help in building the project. So this is kind of a summary here. RFP includes performance requirements on the other side. The design builder comes with different design solutions, try to match these requirements, and then select the best option that deliver the best value to the owner. So the owner here kind of role is kind of giving the design builder the puzzle pieces. The RFP documents, what's the budget, what's the criteria for performance, what is the schedule requirements and performance metrics here. The role of the design builder is to put these puzzle pieces together and within a frame. So they define the frame and putting that kind of maximizes or optimizes the fitting of these pieces together. So the owner requirements here kind of go through different phases, evolution phases, and they kind of take more better shape and better definition over these phases. So they go from functional requirements into performance requirements into prescriptive requirements. And there are different words attached to these. So there's requirements, criteria, specifications. So we'll see in the next slides how these requirements evolve from functional to performance to prescriptive. But before we go into that, design requirements are communicated following industry standards. So in the previous lesson when we covered design bid build, we know that design bid build follows master format kind of standard for structuring and communicating the design requirements and also the cost estimation. Now we'll learn about uniformat. So uniformat is another way to communicate the requirements and design information and building information. So uniformat subdivides the project by functional elements. So a wall, a door, stairs, slab. While master format subdivides the work by results or trades. So concrete, masonry, earthwork. So you see the difference here because the wall can have metal studs, drywall, but master format will look at these pieces differently in different lines. So the focus in uniformat is in the systems and assemblies, but here the focus is on building materials, products, and activities. And this is why it's useful for detailed information during the final design and construction phases, because you have a lot of information. But uniformat is useful for preliminary information in early design phases to give estimate for these. I know there will be a wall. Every room will be having like these walls. I know these type of walls, what's the functional requirements for these? The thermal insulation, the acoustical performance, all of that. I don't know what's they built from, but I know the requirements for their performance. So uniformat will be helpful with that. And uniformat aligns better with BIM models because BIM models are built on a schema that's based on elements. So you can drag in BIM a wall or a foundation. BIM have some level of details that internally, when you draw a wall, you can actually get deeper in detail, but initially it's just a wall. But master formats aligns more with detailed estimates. So when you estimators deal with master formats, engineers and designers early in the design process deal with uniformat. So knowing now about these two standards for design and estimating, master format and uniformat, now let's move into requirements, functional, performance, and prescriptive. Functional requirements are defining requirements that are driven from business, the business of the owner. So the end user, what they want out of that building at the end. Performance requirements describe how the product or components of the product will achieve a specific measurement metric. So they want to look at how the product will perform. Prescriptive is how the product will look like at the end. So they're very more detailed prescription of the product or the assembly or the system. So functional requirements, the first one, it's kind of a top level requirements, and it kind of mandates kind of regulatory regulatory requirements, permitting economic requirements, and here also it describes what functions or operations will end product must perform or accommodate. So it again is driven from the business needs of the owner. So example here is you build an owner. A tech company needs an office space, so you need to build an office space that will house or provide space for 1,000 workers. That's the business need of the owner. How you can do that? What are the detailed description of that? You can move a little detailed description of that using performance requirements. Describe how the product or components do and achieve a performance metric or a measurement metric. So the thing here, the problem with performance requirements is it's in the middle between functional and prescriptive. So your tendency here is to go into the prescriptive requirements. So you want to define things more following standards, not performance. So that's the trip. That's the thing here when you deal with performance requirements. So an example of performance requirements following uniform mat C10. So C10 here, C stands for interior construction. 10 here is an element within it, which is corresponding to walls. And here the performance requirements call for providing durable, paintable interior walls between the office with STC 35 minutes. Minimum, sorry. So STC here is the sound transmission class. So for walls that are separating kind of a function that's very loud, like a studio with the music, and then another space with a function or that requires quiet environment. So you need to have a high STC here. So a specific level of STC. So this is performance. You're not telling how this wall will be built. So things with performance requirements, the challenges here is how you write it. Really, the language here is critical. So first, it should be like when you write things, you can write it in two ways. Non-negotiable, so when you say shall or meet, or interpretational, so will, should, or may. So there is some wiggle space here for the one who will implement these requirements to kind of go a little off or follow this as a guidance, not as a must. So for example here, the system unknown, like blank, perform this number of operations per minute. If you say shall or must, this number should be satisfied exactly. But if you say may, so that's guidance. So you're not going, like now this is a little subjective, but if it's asking for 835 operations per minute, you don't go to 100, but 800 to 900, maybe that's acceptable. So when you write requirements, check these bad examples here: vague, or impossible, or bad words. So vague words like rapid, fast, another, or too clearly, or most, like try to quantify it more. Impossible words like real time. Nothing is real time. Nothing is immediate, right? Or bad words like flexible, adaptable, user friendly. So things that, again, what does this mean, user friendly? Users are different, right? So how you can be friendly to one user there? So just try to explain more. So using vague or impossible bad words, again, so language here matters a lot. The last type of last type of requirements. So we cover functional and performance. Now prescriptive. Prescriptive is easy. It's like a cookbook, cooking approach. So you have a cookbook from your grandma or grandpa, and it tells you bring this material, do it in this step. So it's very prescriptive. So it will describe exactly how the product must be built. What are the different components that you put together? It doesn't tell you how you put it together, but what components be put together here. So the drawings will show you it's a middle stud by this spacing. When you put it, you nail it in this spacing, or you fix it with this nailing or screws, and very descriptive in this case. So here, the idea is prescriptive requirements, you will need it at some point. You have to have prescriptive requirements immediately before you build. But here, the idea is it's developed by the design builder, not by the owner. And it can be also used by the owner in bridging documents. So again, bridging documents is when you start thinking prescriptive. So why owners would go to prescriptive requirements? Lack of trust. So I want to have some kind of confidence in what I will get at the end. Or the owner believe that they know what they want. So I know what I want. Why don't I just specify it? But the problem here is, what if the owner doesn't know what they want, or what if the owner doesn't know what they don't want? So that's the idea: is you're limiting innovation and exploration of different options. So examples of prescriptive requirements here. Another level of uniform. So even in uniform, there is kind of prescriptive, levels within that standard. So it's still in C10, but now going deeper into the levels in the standard here. So partitions. Now you can see here more prescriptive language. Installed gypsum board. So now you're saying it's a gypsum board on middle studs, and you're defining the size of the middle studs and the spacing with this acoustical insulation, this level or rating of acoustical insulation following this type of standards. So now this is very prescriptive comparing to the previous example. So bad things about prescriptive requirements, I'm not saying it's bad, but there are issues with it. First, it's done when you do prescriptive requirements before the design builder is on board. That's an issue. We don't have the input from the design builder. And the bridging here takes away the owner ability to obtain a variety of innovative solutions. So you're very prescriptive. You're not giving the flexibility to the design builder to really shine and give you innovative options here. And even when you provide requirements to the builder, the effort to bridge, so the bridging effort here takes considerable time. So just reading through these requirements, understanding them by the design builder, and kind of knowing what implication of these descriptive requirements, it takes time. So imagine I throw on your table or desk hundreds of pages that you need to read because they're prescriptive. It takes you time to read these and comprehend and understand the scope. Compare that to give you 10 sheets of what I really want out of this project. You absorb it, and then innovations will kick in. So that's the idea, is that bridging takes time to do that exercise of really reading and going over and through these bridging documents. Bridging documents also transfer the risk and accountability back. So it's kind of backward. Now design build puts the risk allocation on the design builder, but now with bridging documents, you're putting it back on the owner. So it negates a lot of benefits of design build. So to summarize here, this is an example of the different types of requirements. So first, functional. If we're talking about air conditioning or kind of environmental control, so that's a functional requirement. A system in the building should perform environmental control. That's functional. Performance requirements, it should do heating, ventilating, and air conditioning. So That's the performance. It should heat, it should ventilate the air, and condition it. That's then performance criteria. Then you start mentioning standards. So it comply with ASHRAE design criteria. Performance specifications. Now we start putting more detailed numbers into what would be the expected outcome. You didn't say yet what type of system, but you want to specify how the system will perform. So here it maintains that interior temperature with exterior temperature when the exterior temperature is that. This line here is very important. Now you're going into really the dark side, kind of. So the prescriptive specifications. Now you say, for the heat pump within the system, use this ABC company model XYZ. So it's very prescriptive. So in design build, DBIA says it's fine to provide these requirements here, Mr. Owner, from functional all the way to performance specifications, but don't cross this line, because this line here, the design builder will take that and translate it into prescriptive specifications. If you cross the line, then you're going into design bid build, not design build. The last thing to cover here is design excellence. What does design excellence here mean? And it's actually one of the things that are used to differentiate between different proposals. So if you look at this picture here, some of us will say, that's an excellent design. I really like the design excellence here. Like, what does it mean? So if you're gonna pick based on design excellence from the proposals and design build, define what is design excellence. So kind of put some description to it. What does design excellence mean to you? Because every one of us has different definition of design excellence. So we learned about requirements. So owner requirements is a big deal. It's actually really the communication part of design build. It's how the owner communicates what they want. Do they want to focus on functional aspects of a project, or performance aspect of a project, or prescriptive? And DBIA says that don't provide that much prescriptive requirements. Focus on performance requirements and performance-based selection. So thanks for watching, and I'll see you in other videos.